Hi dear students. So let us see this question that came in JEE Advanced Paper 2 Physics in the year 2022. This was a single digit integer type question. That means the answer to this question will be a single digit integer. And if you get that correct, you get plus 3. However, if you get that wrong, you get minus 1. If you leave it unattempted, then you will get 0. We are going to see two solutions to this question. Actually, there are three, but the third solution is absolutely very long. It requires like integrating the force equation to get velocity as a function of time and then integrating it further to get the position as a function of time. So we are not going to discuss that. We are going to discuss two other solutions. One of them will involve conservation of angular momentum and second will involve SHM method. So we are going to see both of these solutions in this, right? So let's quickly see the data of this question. Now, what is happening over here? Uh, Basically, this is a particle of mass 1 kg, which has been acted upon by this type of force. The value of k has been given to be 1. Sorry. The initial position vector has been given to be this. Velocity initial has been given to be this. We have to find the value of this quantity when z becomes zero point 0.5. Now, if you carefully look at the force is of the type uh, minus xi cap plus yj cap. Now, if you look at it carefully, then this force is always going to pass through the z-axis. Mind you, this force may not pass through the origin. In many of the other sources, you would have seen that this force is passing through the origin, which is not right. The force always passes through the z-axis. Let us see this why. For example, consider a point in the xy plane. For the time being, assume the z coordinate to be 0. That means let us assume that particle is in the xy plane as of now. So as of now, I'm saying the particle is in the xy plane, which may not be always right. That even if you see that here z is equals to zero point 0.5, that means particles z coordinate, of course, will change. It has also got z velocity. Anyway, so as of now, I'm assuming that particle is in xy plane. So then you can carefully see that this force is passing through this point because you can see that this is a like if you take the unit vector of this, what will be the unit vector of this? So f cap, if you see, then this will be x upon under root of x square plus y square I cap plus y upon under root of x square plus square j cap, right? And since it is negative also, so you can say that it will be directed towards the like towards this origin. Okay, so I hope you realize that if particle was in xy plane, then this force would have been directed towards the origin, correct? F cap. But imagine if this point is not in the xy plane, and if this point is somehow like no outside the xy plane, that means it has got some positive or negative z coordinate. So you can see that this point is going to come out of the screen or maybe going inside the screen. In that case, if you assume this type of z-axis, then this force will be passing through the z-axis, not the origin. So we realize that force always passes through the z-axis. Hence, the torque will be zero about z-axis, right? So we can conserve the angular momentum about the z-axis, right? So that is what I'm going to use, right? So now let us again see what will constitute the angular momentum about the z-axis. So actually this itself is nothing but the angular momentum about the z-axis since the mass has been given to be 1. Why? Let us understand very easily. For example, again assume that particle is in the xy plane for the time being. Okay. So if the particle is in the xy plane, we can say that this is x comma y, so this distance will represent x and this distance will represent y, right? Now, so so let's say this is the Vx component, okay, and this is the Vy component, and particle might have some Vz component as well, okay. Now, if particle has Vz component as well, then also that is not going to constitute any angular momentum about the z-axis because that Vz component will be parallel to z-axis, so it is not going to contribute anything about z-axis. Okay, so what will be the angular momentum about the z-axis due to this Vx? So of course, if we take anti-clockwise direction to be positive, then basically or I'll take clockwise to be positive, because in this the clockwise has been given, like Vy wala has been given as positive. So if I take clockwise to be positive, then if you see carefully, then Vx thing, this Vx is going like this, and this is y, right? This distance is y. So Vx into y, this is the angular momentum due to the x component of velocity, and this will be taken as negative because this angular momentum about z axis is in the clockwise direction, correct? So this angular momentum about so I think I said it other way around. I'm taking clockwise to be negative and anti-clockwise to be positive. Okay, I think I said it oppositely. I'm sorry for that. So the angular momentum due to the x component of the velocity about the z-axis is in the clockwise sense, and I'm assuming clockwise to be negative. Okay, I'm assuming anti-clockwise to be positive. Okay, I want you can take any direction to be positive or negative, but I wanted my direction to be aligned with the expression given, right? Okay. Similarly, if you write the angular momentum due to the Vy, so this will be the distance that you're going to take, which is nothing but x, and this angular momentum about the z-axis will be in this sense, which is anti-clockwise. So we can say that Vy into x. So this is the angular momentum about the z-axis. Now, even if you take this point above the xy plane, or like below the xy plane, you can still see that the distance of this point, that means the x component is not going to change. That means what I'm trying to tell you here is that this distance is not going to, this x coordinate is not, will be unaffected even if you bring this point outside the screen, or like if you push it inside the screen, this distance will not be affected. And similarly, this distance will not be affected, Vx will not be affected, Vy will not be affected. Hence this itself will remain the angular momentum about z axis, right? So you can, and we have already proved that this thing will remain constant, so you can compute its value initially as well. Initially, what was the value of Vy? So it was root 2. What was the value of x? It was 1 by root 2. And what was the value of Vx? It was minus root 2. And what was the value of y? Y was root 2. So you can see that this comes out to be 3. So this expression is going to remain constant, and it comes out to be 3. So I hope guys you would have understood the method number 1. Okay, so this was method number 1. Let us quickly look at method number 2. Okay, so for method number 2, if you see that fx is given as minus x because the value of k was 1. So this mass is also 1, k is 1, mass is 1. So we can say that ax will be is equals to minus x. Okay, this allows us, now you can clearly understand that here, if you compare that, if you compare this with ax is equals to minus omega square x, which is the equation of shm, then you can write x is equals to amplitude a1 sine of omega is 1, as you can clearly see, plus some initial phase phi 1. Similarly, Fy is equals to minus y allows us to write y is equals to a2 sine of t plus phi 2. Right? These are the equations that we can make for this particle along x and y axis. If you differentiate this, you're going to get velocity in x, which will be is equals to a2 into cos of, sorry, not a2, this will be a1 only. So a1 into a1 into cos of t plus phi 1. Similarly, if you write this as Vy will be equals to A2 into cos of t plus phi 2, right? Now, we can find the value of A1, A2 and phi 1, phi 2 using the initial conditions at t equals to 0. At t is equals to 0, you have been given that x was, let us quickly see what was x. X was 1 by root 2 and Vx was minus root 2, correct? X was 1 by root 2 and Vx was minus root 2. Okay. So if you put t equals to 0 in these two equations, what are you going to get? 1 by root 2 is, you could have found this value using phasors as well. A1 into sine phi 1. Okay. And similarly, minus root 2 will be is equals to a1 into cos phi 1. Okay. So from here, if you square and add these two, you're going to get a1 is equals to, a1 square will be is equals to 2 plus 1 by 2, that is 5 by 2, which implies a1 is nothing but root of 5 by 2. Putting back the value of a1 in this, you will get sine phi 1 as 1 upon root 5 and cos phi 1 as minus 2 by root 5, right? Similarly, uh, for the y-axis, we can do the same thing. At t equals to 0, the y was given as, let us quickly see what was the value of y. Y was given as root 2 and Vy was also root 2. So here y was root 2 and Vy was also root 2. So again doing the same thing, we can say that root 2 will be is equals to a2 sine phi 2. Okay. And root 2 will also be is equals to a2 cos phi 2. Correct. So from here we can say that a2 will come out to be 2, sine phi 2 will come out to be 1 by root 2, and cos phi 2 will come out to be 1 by root 2. Correct. Now just so we have gotten the value of x, vx, y, vy. So just use this value to compute this vyx minus vxy. Okay. So I'll do this here itself. Okay, in this box so that you can check the values. I'll just make this box. Okay. So if you see x vx, so x vx minus, no, it was x vy, I guess. X vy, yes. So it was x vy, x vy minus vxy. So this will be is equals to x का value हो जाएगा a1. So you can see you will get a1 a2 sine of t plus phi 1 into uh, cos of t plus phi 2 minus uh, cos of t plus phi 1 into sine of t plus phi 2. So using the formula of sine a cos b minus cos a sine b, you are going to get sine of a minus b. So t will cancel out and you're going to get sine of phi 1 minus phi 2. I hope you understand this, because sine a cos b minus cos a sine b will become sine of a minus b. Now just put the values. So a1 a2 we had already found out. A1 was root of 5 by 2. A2 will be 1 upon root 2. No, A2 I think came out to be 2, right? A2 was 2, yes, sorry. So A2 was 2, okay. And this you can expand. Sine phi 1 cos phi 2. Sine phi 1 was 1 by root 5 into cos phi 2. Cos phi 2 was 1 by root 2 minus cos phi 1 was minus 2 by root 5. So this will become plus. And sine phi 1 was 1 by root 2. Okay. So let us see what do we get from here. So root 5, root 5, root 5 gone. The outside will become root 2 and it will go inside. So it will become 1 plus 2. So this will be 3. I hope you would have enjoyed both the methods. As I said, there's one more method, but we are not going to use that. Thank you.